All right, let me know if you're not hearing from the back. Actually, everyone has a headset. Why am I saying this? Sorry, it's a bit weird for me to have the headsets. Looks like aliens for me to hear. Hey, so first of all, this is a session that it's a bit different than the usual of AWS, especially when someone from AWS trying to learn something and they want to share some use cases. So this is that type of session. My name is Lessa. I'm a serverless lead for AWS Well Architected. I basically help define best practices and aggregate those for serverless customers. So think about how AWS customers use serverless, what are the common patterns, anti-patterns, how should they use. That's exactly my day-to-day basis. And this session is a mix of how I ended up learning Frontend and design, completely different from what I know. I come from backend and ops background, and how that made me a much better engineer. So I want to show you, if you were to build a web app from scratch today, how would you do it? So that's exactly how it goes. We go from the very scratch, from the design idea to prototyping, CSS, obviously, and then we go over with the payments pieces and every component of apps. So a quick recap on the agenda, real quick. We're going to do a recap on the Amplify toolset. I've spoken to a lot of people this week already, that everyone seems to think that Amplify is only the CLI or the front-end JavaScript. It's actually more than this. So we're going to be covering some of those misconceptions at first. Next, we're going to be covering the serverless airline use case. This is actually about 3 months of content in a single hour session. So we're going to try to cover as much as we can, but all of this is being recorded as well. We have 14 hours of video building this from scratch as well. So we're going to share you the link so you can watch it if you wanted to, including my silly mistakes on types and everything else. Also, it's important to set the expectations of what we're not going to be covering. This is a 300-level session, so I have some expectations from you about you as well, on what you know. We're not going to be able to introduce you to AWS Lambda, all of its features, so some of the services we use. I will briefly touch some of those services and why we use them, but I'm not going to be able to dive into every specific feature of how they actually use and why they're useful. When it comes to serverless, there's a bunch of definitions that you probably see out there. I've been trying hard to find a way to explain in a much easier way for people who probably haven't used AWS or used that extensively. Think of serverless as a X spectrum. Everything on the far left-hand side, you would see virtual machines or VMs, traditional databases, and things like this. On the far right-hand side, you'll see fully managed services that would help you with scaling and high availability and cost and some of the other pieces. What you find in here is more of a kind of a showcase, a journey, where you might be using some of the Lambda functions or no Lambda functions at all, just GraphQL, for instance, or some of the databases, traditional databases. You're going to be mixing, matching some of those as you go along, depending on what you're working, the feature, the use case. It's not always going to be either full left or full right, but it's important for you to understand how it distinguishes. Also, when I put in the deck, that's a Fullstack app, I've been asking people all along, what do you mean by Fullstack? And I've got completely different answers from whoever I was asking to. So my own definition of Fullstack now is as someone who can build an application, be that from the front end or the back end. It's a builder. Some people actually get more flexibility and more knowledge into front end, others back end. At the end of the day, you are paid and I am paid to build solutions. That's what matters. Whether you're using code for front end or back end, the customer's experience is what matters. So, oh yeah, by the way, and for this whole presentation, especially from CSS, it was pretty much changing stuff here and seeing what happens. I will show you some of those things as well. So, recap on Amplify. The easiest way to explain Amplify comes in 4 pillars. You have the CLI piece, you have the platform components, whether you're using mobile or web app or whatever that is. Think about authentication components for having sign-up, sign-in flows in general. Also the client libraries. Not only is JavaScript library to interact with AWS, databases, APIs, web storage, whatever that is, but also mobile. And lastly, Amplify is also an AWS service on the console to do CI/CD for you, hosting, custom domains, that sort of thing. If you're ever doing single-page applications on AWS today using S3, Amplify console is definitely something you want to look at. From the CLI, It looks more or less like this. Once you install the CLI, these are the common flow everyone's going to be looking at first. You initialize a new project, you add a new API, GraphQL or REST, and that's new, Amplify mock from the past couple weeks, let's say a month or more than a month actually. That Amplify mock not only will mock the entire API locally, GraphQL or AppSync in this case, but it will also launch DynamoDB locally for you, including WebSockets locally for you, and all the joins and stuff you normally do in the console. Amplify push, as you can guess, is already pushed all the changes. And update API, update off, all of this is categories. You probably have noticed on AWS has SAM CLI, Amplify CLI, CDK, AWS CLI, and a bunch of these things. What makes Amplify unique in this scenario is the first line. Amplify CLI follows a convention over configuration. If you want to do authentication on your app or your mobile app or web app, you just do Amplify add off. You don't need upfront knowledge of Cognito and how it wires together all these pieces. And then later you can change this configuration if you need to. But it's different from SAM or others that cover something like, if you want to do Cognito, this is how you should configure. It's much more granular. Amplify thinks about what are the common practices that people use. Let's vend that into a CLI for you. The client, it looks more or less like this. This is one of those features that I picked up. On the top is what I normally use all the time. When you're trying to make a request to a GraphQL or a REST database or REST API, you import that API and you just do API get, post, etc. It handles things like rotating credentials if you're using Cognito. It handles things like retries and a bunch of other common practices you normally use in a very concise way of calling it. That's also available for a bunch of other frameworks. Vue.js, the best framework in the world, obviously. But you also have Angular, have React, maybe Ember one day, don't know. And then on the left, you can see how you could use the platform components with authenticator in React, similar to Vue and Angular. That alone would simply do sign in, sign up, all these pieces you normally would need in an application, including forget password, all those sorts of things. And this is Amplify console. This, for me, was a big changer when I was trying to do a basic blog, trying to do using Hugo, for instance. All I needed to do was actually deploy a single-page application or a blog that I could have custom domains, feature branches, all the common pieces you normally would expect, multiple stages, environments, just pointing to a Git repository. That's done. You get all of this for free. Well, for free, I mean, easy features. And last week, actually 3 weeks ago, we announced this. If you have a pull request on GitHub and you enable that feature, this is only enabled for private repos to save you from some cost of the environments. But once you enable that feature, even on public repositories, once you have a pull request, a CI will be run and create a full ephemeral environment of everything you have, API, database, etc. And once the API has been merged, everything gets deleted automatically as well. That's something that I've started to use as well, and it's pretty neat. OK, so let's start with the main piece now. Let's start with the meaty, or veggie for vegetarian. I like to see some smiles. You're still awake as me, so that's good. All right, so the main thing here while we're here is a serverless airline. Imagine someone who never done any color, any design, that was me. Well, that's kind of me still. I wanted to learn Frontend because I always wanted to see what front-end developers go through on AWS and what exactly they go through from toolchain, et cetera, et cetera, et cetera. It's easy to get stuck on your own bubble and kind of work with backends every single day, distributed systems. Those are all nice. But what I noticed after years of serverless is we're always trying to write as little logic as possible, only business logic, and get close to the customers. Front-end is the closest to the customer. All you're dealing with is the customer experience. And I thought, maybe I should try this. Maybe I will spend a week learning it. Well, turns out it was a whole year. How do you start? Let's say you have an idea. You want to learn front-end as well. Or you want to learn how to do a web app. But you don't want to do a to-do app. You want to do something more complex, but not so complex that you kind of give up in the middle. Where would you go? So I've tried so many websites, and these are the 3 ones that I used, and I think you could like it too. The first on the left is you're looking for inspiration. You don't know what to build. You want to see some cool designs that people are using it. Those ideas already exist, But you want to have a feeling of how people are using it, how people are designing, the user experience. Maybe that's something that piques your eyes. So airline was one of them that came from there. But I've noticed that e-commerce is all over the place, as always. You have things like meetups, you have hotels, and a bunch of things. The one in the middle was a lifesaver for me. I haven't studied about colors. Now I did a little bit. All you do in this website, you can even do it on your mobile, and all you do is you press spacebar, and that will generate a color palette for you that looks good. And then if you just say lock this primary color on the first one or the secondary color, as you keep pressing bar like a maniac, you will see all these new colors being generated until you like one. That's it. That's really simple. The third one is something called mood board that I learned, at least though. Well, if that's wrong, please correct me. In Vision app, imagine as you're trying to come up with an idea and you visit so many websites to see how things are implemented. This allows you to have a canvas where you kind of copy and paste all these ideas, screenshots, and then later you can kind of reorganize and kind of have an idea what you're going to build next. So that's what I use, including the colors you can see on the right-hand side. They even have an IDE to make it web development easier, but I couldn't use that one yet. So check it out. So after doing all this, I used an app called Sketch, and I came up with something like this. After a week of trying, playing with stuff, one thing I've learned as well from these web development pieces were trying with the HTML and CSS is like it's leading for failure. Like it's very frustrating to get something working at first if you don't know what you're doing. Starting design first, just a sketch, it makes it easier for you to experiment. It makes it more, you have more freedom to do whatever you want. Except I had way too much freedom that I thought some things I did in there, it wasn't possible to do in the browser. But still, at least in my basic skills. So how do you start it then? So this is kind of the nice pieces. We're here for the tech, right? So prototyping, that's how we're going to start. I'm going to be filling up this with all the technology choices I've made, but just to give you an idea. So the first one, all I wanted to do was a front end, to call an API, and then that API could call multiple other APIs if I needed to, and that each of those microservices would have its own database and things like this. The pieces I know really well is API and above, and below. The front end was new. So the UI, UX, I chose Vue. I've been asking for help for which framework should I start. Vue.js, to me, it was actually the easiest to start. Not only because it's the best framework, but it's still, it's so easy to start compared to everybody else. But React and other pieces, now I understand it. Now I see the value of why it's so popular as well. Quasar framework gives me the UI, all these components you're going to see in other pictures. It's basically all the interaction, the user experience comes from this. It's simply amazing. Their documentation is one of the best I've seen on the internet in terms of frameworks. They also provide you a CLI that you build at once, and you build as a web app, you build as a mobile app, Electron app, or server-side rendering as well. And then obviously Amplify for all the CI/CD and many things, and then Stripe for the payment pieces. After a month of trying and hard, that's what I came up with. This is the real CSS pieces working. You can see how much of a difference it is from the sketch. So the airline, the idea was the airline is that I should be able to search for a flight on a particular destination. And then you get those flights, and you should be able to pay for a given flight. And once you pay for the flight and you book successfully, you are supposed to earn points, like a loyalty system. So how would you start? For the first thing, you start with authentication. Using Amplify, first you need to do the infrastructure piece before you even do the components on the UI. So by doing Amplify init off add, that already gives you all the default settings you probably need for your app. That covers sign in, sign up, change the password. If you want to do reCAPTCHA or custom workflows or admin, custom attributes, groups, all of this is done here. Just by that single command and then start answering some of those questions. That will set up Amazon Cognito as a managed service to handle all of that for you. Next, you need to do some of the UI pieces. Not sure how readable that is from the back. We are using Amplify platform components to basically render this username, sign-in account, password. I did nothing for this, but just saying import Amplify, Amplify Authenticator, and that was it. nothing else. As you sign up, you can even customize and say, ask additional sign-up fields, give a name, last name, or anything like you want. So coming from this idea, you have the very basic now. You have the UI, you have the UX, and now you have the auth. The first thing I love to do it was, OK, now I'm ready to do some of the basic APIs. Where do I start? My personal preference for any APIs, I always start with a JSON first. Have an idea on how I'm going to be placing the JSON and how I'm going to be working with that. So from the API, I started with this. That's how the JSON I started first. Yeah, hold on. Yes, that's right. So this was the initial idea of how the data was actually looking like. That's how a flight would look like, the booking data and the loyalty data. I've done some research on how airlines actually work. Obviously, they're doing stuff way more complex than I need to do. It's just myself, so I needed to do something simpler than that. Or for instance, you cannot book a return flight. You can only go one way. You never know, right? You could go to Caribbean. And from that JSON, it looks very similar. Now I have a GraphQL type. This, for me, was the game changer on AWS. That was like the game changer personally for me after Lambda. Once I saw this, I was like, this is exactly how I normally think. I think about the business first, how the data should look like. Then I can create an API from this JSON, this idea, from this mock. I can basically mock this and run it locally, so I can have an API already functioning without doing any code. And once I'm ready, I can start doing the real things. This is something called Amplify GraphQL Transformer. By doing that at model, what you are signaling is that type booking should live in a DynamoDB table, in a NoSQL database. And I want you to create, update, delete, and list, and get booking for me without any coding whatsoever as well. And you probably don't see it, but there's a field called outbound flight, which should go to a flight definition of the data as well. That's exactly what I do next. I do an add connection. Once I query that booking data, and if my front end selects the outbound flight, it will go to the flight table, get the flight that I need to fetch, the specific ID of that flight, and then it will merge all this array and send it back to my front end. So I know exactly what I need to do. All of this is still local. I can still do all this locally with no deployment whatsoever. So that's how I started to iterate and prototype that quickly. Next one is, it wouldn't be real if I were to have a booking that everyone could see it. So I wanted to start getting some more production pieces slowly. So this is how you do authentication in fine-grained detail. We can go even further, which I will show you the final schema, but just so at least it fits on the screen. What you do with auth, you say, allow only the owner of its own booking, which will be the customer, which you see the customer field right there. You can change it if you like. And only allow people who have admin permissions to see other people's bookings. Otherwise, one person could only see its own booking. Well, you can go even further. You can start saying, whoever owns the booking could only read the booking but not make updates or things like this. Again, no coding involved yet. Let's get to something more complex now. You already know the basics. You know the authentication now. But this has one problem if we're going to production. Don't go with production like this. If you go with production like this in a large scale, the at model lists all the bookings if you wanted to, unless you get a specific booking. If you list all the bookings, you would do a scan on your table. So that means performance is not going to be good. How can you fix it? Use at key. By doing this, it basically creates a global secondary index where you can say, what is the name of the new query that you want to create? And what are the fields that you want to use? The secret from here is that we're using only two fields, customer and status. However, as you can add as many fields as you like. And if you don't have DynamoDB, you can only have a primary, secondary key. But once you have a third field or a fourth field, you're automatically doing composite keys without even knowing it. Then with these additional fields will be hashed, and we'll handle all of this at GraphQL layer. No coding involved still. Nothing that you have to done. With that in mind, the front end looks more or less like this. Coming from the back-end idea, you have the front end now using multiple components or modules. And then each of those are responsible for their own states, their own data fetching to each of their own API. and that they should be able to handle all the data mutation and the state themselves, or getting setters, all these pieces. That makes it easier to code for me, and it makes it easier to know exactly if I want to troubleshoot loyalty API, I go specific to the loyalty component. By running that, essentially what you do behind the scenes, infrastructure-wise, the at model, everything we've seen it, actually does this. This sends a signal to AppSync to generate all the code you need to fetch the data, create, update, read, and delete, including the authorization details, global secondary keys, and all those performance enhancements. There is no Lambda involved in here yet. If you don't need any complex additional logic, like basic filtering, basic sorting of the data, you don't need a Lambda. If you go further than this, then Lambda becomes necessary for that. Next piece is about payment. Payment is a two-way street. First, you need the front-end, the UI pieces. Stripe.js and Stripe elements makes it so much easier to do this. I'm not sure if you can notice, unless your eyes are really, really sharp, card number, expiry date, and CVC are actually not real fields in my UI. These are actually an iframe that goes to Stripe. Then Stripe gets back to me using events and tells me that card number is invalid, so then my front end can say, oops, you cannot send that data yet. I cannot tokenize that card. That helps with PCI DSS and a bunch of security concerns as well. I'm not dealing with your sensitive data. Going straight to Stripe, and I can handle that. Then you need to do the backend piece. Once you tokenize your card, that token of your card details you need to send to Stripe so you can charge, refund, do whatever you need. That piece, you need a Lambda for that. However, the good news is that if all you need to do is work with Stripe in that simple manner, you no longer need to code this. There's now on serverless application repository, which I can show you, one-click deployment can handle this for you as well. We've done this as part of the tweet series to make it easier for you. So if you want to do a hackathon, you want to cheat, you can do this now. If we go back to our list of the tech that we've chosen so far, we will now update that with, hang on, I'll go back there, and you can take a picture. Go. That's fine. So we've got UI, auth, APIs, and data using GraphQL and DynamoDB. We also use API Gateway not only for Stripe, but other pieces you're going to see in a minute. Right, now my favorite part now to make it more prod ready, and one of the reasons you're here. I've used a bunch of advanced features of Amplify, so I've tried to make it as easy as possible to digest. If something is not clear, please feel free to ask me the questions afterwards so I can show you. And I can show you the more advanced pieces I couldn't add in the presentation itself. The very basic of operations, we're already talking about 3 APIs easily and a bunch of other operations. As you start dealing with microservices, it's nearly impossible just to have logs. It just doesn't work. You need to have some sort of tracing to know which part of your system, was that downstream, was that upstream, that was starting to be a little bit slow. More importantly, tracing, just by instrumenting your code doesn't help. If you're dealing with multiple developers working the same system, you need something extra to just do the tracing. Some of the reserve confirm booking that you see out there, if I were to click in one of those circles, which I will show in a demo, I would also see what was the customer that initiated that transaction, which state machine started all this, what was the API ID, what was the correlation ID, all of those pieces you can do it. I can show you in the code as well. Remember when I said that at model, it's not a good piece to go to production? This is how we tested. We used a tool called Gatling to do a load testing to actually get a better sense of what are good defaults, what are the pieces we needed to change, and why. So at least we are changing and we're documenting those things. What you're looking at, it might be hard to read, I suppose, but we're looking at searching a flight by using table scans. And we changed this to that add key optimization that you saw it. Just by doing this, the worst case scenario went from 2.3 seconds to 250 milliseconds. So you can see the difference when you're searching for a large amount of data. If you're only searching for a tiny bit of data and doing pagination tokens, you don't need that sort of optimization. But in this case, I wanted to show you. But we don't stop here. If you already use Lambda or API Gateway, the next one might surprise you, as it surprises many of people. By default, when you use REST APIs on AWS through Amazon API Gateway, if you use CloudFormation to set all of this up, API Gateway has 2 modes, Edge and Regional. Edge gives you ability to work with customers globally. But if your customers are coming from the same region, it doesn't make sense to have a CDN on top of it. So regional makes it more sense. When you're dealing with service-to-service communication and put an API on top, you don't need a CDN to go back outside, come back again. That adds too much latency. By changing the API gateway to regional, that not only removes the CDN part, less networking hops, but it also enables HTTP2, which improves our connection time. And Lambda by default, if you haven't used that, the memory setting that you use allocates CPU, networking, and I/O proportionally. So less memory, most of the time, is bad news. The more memory, you get more CPU and more network. If all your Lambda does, in our case, is talking to Stripe, talking to something else, you want to crank that up and trying to load test to see what was your best memory. But instead of doing this manually, I can give you in the appendix, but there's a tool called Lambda Power Tuning. That open source, if you look up GitHub Lambda Power Tuning, you can say, try this Lambda function 10 times, 100 times, and I'm looking to optimize for performance, cost, or a mix. That will execute your Lambda function a bunch of times, and will tell you which memory you should use. It's a much more systematic approach than trying again, try and changing. This was announced last week. I couldn't test it yet, but I will explain to you why it's a game changer. When you're using in prod, you definitely don't want to keep going to the database every single time. In REST, it's a bit easier to cache because it's very, very well accepted, it's very well known, proxies and things like this. GraphQL makes it harder because when you think about caching, the front end decides what data they want, specifically what's the format. That makes it harder to cache compared to REST. But now you can have the ability to cache at the server side and AppSync. You can cache at the API level. No matter what API call you use, mutation, queries, whatever it is, you can cache all that if you like. Well, query in this case, not mutation. Or you can do what I prefer now, is you can do a per resolver caching. If you're using GraphQL, one of the main benefits is using different data sources. NoSQL here, full text search somewhere, relational databases here, or even no database whatsoever, just a mock or something. So this allows you to enable cache not only for a specific data source, but also a field and per customer authorization session, which is something I've never seen in the industry before. So this is a huge announcement. If you haven't seen it, go experiment with that. The next one, if you've never seen it, by default, this is disabled on AppSync for cost reasons. But once you click in AppSync and say enable access logs, that will appear to you. Actually, yeah, I will show you. So you can create custom metrics from AppSync using Elasticsearch and a bunch of other ways. But what you can get, which I actually got ahead of myself, is actually this. You can say, show me where the latency is. Show me in a per field, what is the statistics that's causing my customer experience to be slow. And all of this is already in the console. Once you enable access logs, you get access to this. And it will show you the field, what is the field key, what is the operation, the statistics, P99, minimum, maximum, median, and things like this. So that's actually a super key one to use it. And there's another one as well. We can also find all the resolvers that had issues for the last X amount of time. So you can quickly see what's going on as well. Let's talk about Lambda. No matter what backend you use, tracings are great. But the challenge of traces is it's simple. So if you're trying to find out a specific request, it may not be in the trace. And you don't want to be caught in that situation. So instead of logging every single line, what you want to do is structured logging. So you have to define a number of keys that are always going to be present across your logs. And once you define this, you can just convert the output into JSON. So when I do log.info for my Lambda function, that's the message, that's the output I'm going to get. Whether it was a cold start, which service, which Lambda function, what was the memory, and things like this. So by doing this, that goes to cloud.logs, and you can use any tool that you like to start doing some analytics on your logs, and this, or this, concatenation, and things like this. From the front end, one thing that I missed, but is now is a new feature, is what if you wanted to do a correlation ID across all of your services? Depending on which service you're going to use, you could do it at the backend level. But doing the front end level is much easier. what you do here, you say every time Amplify is going to call AppSync, add an additional HTTP header that has a particular UUID value, and you can propagate that, which we will, across all those services. And you can use that as for tracing, for logging, anything you like. Security is one of my favorite ones. Remember when I said that by default, auth allows you to do many operations and fine-grained details? Especially when you're using JWT, you could also change the field that means owner. In this case, I'm saying now that owner is whoever has the customer field being the same value as it was before. And you could also specify operations, and you say whoever is the owner can only read and update their own booking, nothing else. They cannot delete their own booking. They have to go to a separate system, except everyone who has an admin privilege, they can do anything else. And you can do this from not only per type, but also per field, which makes it even more interesting. At the top, if you're not using real-time, if you're not using subscriptions in GraphQL, disable that. You don't want additional attack surfaces. Simply do a subscriptions column no, and no auto-generation. None of these things will be generated for you. If you want, if you don't have that, basically you have not only create, update, read, delete, list, and bookings, but you also have on create booking, on update booking, on delete bookings, and things like this. This is kind of a low effort, but it pays dividends really quickly. If you haven't seen this before, these are some of the basics HTTP security headers you want to have. There's more than this. There's also CSP, but it didn't really fit into the slides. So I'll just call out some of those. Imagine that you created a web app, it became really popular, and someone tried to get your web app into an iframe in a completely separate domain that you forgot to buy or something. So you can protect against that by just saying XSS protection. Sorry, X-frame options. Or say that you're dealing with a website that has a lot of sensitive data. When someone clicks, it goes to a separate website that you don't want to send specifically where that customer came from. What was the link they clicked? What was the source? You can simply, the referer policy, you can say, only show where the customer came from, the HTTP referrer, within your own domain. And the last piece, it's quite similar to CSP or content security policies. My website, my airline, doesn't need to use your microphone or camera or anything like that. So you can disable all these features, even though those extensions in your browser could try to use it. So if you're an architect, that's the section for you now. How does that look in architecture terms? Let's go from a high level now. Let's say we get to a flight that we want to search. As soon as I click that button, go to Frontend, fetch a flight, go to AppSync API using Amplify, and then we use VTL Apache Velocity template, go straight to DynamoDB table, job done. At first, looks super easy, it just works. What if I want to start payment? So similar to what you already know, once I click agree and pay now, before I start a booking process, you go to API Gateway, Lambda, Stripe, do a pre-authorization of that, and then if it's successful, then I go to the next step of trying to do some booking processes. So from here, normally you would see a bunch of DynamoDB being called and a bunch of Lambdas being called, but we decided to do it differently. One of the tips is, if you have 2 transactions only, or something that can finish really quickly, and you don't need to do any try catch, errors, retries, and things like this, just by using 2 transactions, it's easy, it just works. But if you have something more complex than that, integrate with step functions or any state machine that you can use. So that actually looks like this. If you've never seen this before, this is what we call Saga. That booking returns successfully, so we can pull that, or we can even do a real time, which we're going to do it soon, by January or February. But what that does is that on the right-hand side, this is what we call the happy path. Ideally, if everything works as expected, I should be able to reserve a flight, reserve that booking, collect the payment, and go and keep on going. But sometimes, as you know, the network is not reliable. Something can fail. Lambdas could fail. Something could fail. So if that fails, I could retry that a couple times, but I should never keep retrying forever. Maybe I set a max retry, or max errors, or max timeout. And when that happens, those arrows coming on the left-hand side, on the red boxes, are steps that can help me clean up the state where it's supposed to be. If I collected payment, but I couldn't confirm the booking because database is having issues or whatever it is, I should refund the customer. And you can actually run this for up to a year if you like, per customer. But nobody wants to wait for a year to get their booking, right? Once you get the booking and you list the bookings, remember when we had the outbound flight, add connection, those things? Behind the scenes, that's what happens. As you list those bookings, AppSync will know that the data field outbound flight, it's not from the booking table, and it has, therefore, to go to the catalog database to fetch that data. Then it goes back, merge everything, and it sends as if it was a single request to a single place. That's why it makes GraphQL so unique on that one. You can go to many data sources, and it doesn't matter. Your front end will always going to receive the data in the contract they know. Next is the loyalty. Once you search for the loyalty, I could have done it differently, but I did this way to show you one scenario that I haven't seen yet on GitHub. What if you're trying to modernize your application, but instead of doing a big bang approach as we did here to showcase, what if you already had an API in place and you wanted to have GraphQL on top to start modernizing some of those things on the front end? Well, in this case, you would need to do a HTTPS integration with your existing API. And in this case, we're using IAM to do a cryptographic and very strong authorization as well. So that API, even though it's public on the loyalty, only AppSync can actually talk to them. And I can give you the template and the source code to show how you can do this. And that means I can use now AppSync as a hub for many, many, many APIs, and I can still add functionalities over time. As I search for that particular loyalty and I want to get more loyalty, I need to know how it calculates. Once a booking has been confirmed, a Lambda function as part of that state machine, that confirm booking, will send a notification to Amazon SNS in a topic, like a fan-out approach, and we'll tag a payload that says, booking has been confirmed. And that Lambda function will only be executed if the payload has a tag booking confirmed. The reason you do this, you don't want to keep sending multiple notifications to Lambda function for invocation when you don't need it. That function will only calculate loyalty points if a booking has been confirmed. If it doesn't, there's no need to invoke that function. Now that you're an expert, you probably know all this now. So this is kind of what it looks, or at least the last snapshot I took. In February, it may look a little bit bigger, but at least to give an idea for now. Kind of a recap on the architecture per se is you've got a front end talking to AppSync. AppSync as an API hub goes to catalog to fetch new flights, book those flights using a state machine asynchronously. That spins up multiple Lambda functions, and I collect the payment. I go straight to API gateway from my Lambda function, go to Stripe. Once the booking has been confirmed, I go to loyalty and say, ingest that into me. And then when I want to get loyalty, AppSync goes straight to the API gateway, a different Lambda function, and do the calculation for me. All right. So now that you're an expert, I will show you how that actually looks like as well in code. Sorry, go ahead. So if you want to have a quick sneak peek into the code and everything that we've done, that's the URL for that one, or QR code. If you are interested in the optimizations perspective, I created a pull request just for this. All the load testing behaviors, how we optimize for performance, how we optimize for security, and a bunch of things. There's a PR specifically for that. If you're looking to do the same load testing on your own as well, there's an open PR for Gatling as well. There's a bunch of PRs that you can go and learn, or you can also watch the Twitch on how we've done all of this as well. Before I show you all the demo as well, I just wanted to point out one thing. There's one of my colleagues called Joe Emerson on Twitter was asking every AWS employee to showcase, whenever they build a new example, to showcase the effort. How long it actually took, how many lines of code you actually had to write. And I thought, well, fair enough. Let's try that. So I tried a bunch of combinations to fit in the screen. So what I came up with was something like this, to showcase how much of an effort it was. For me, with no front end, no design experience, some on jQuery, so you can call me web engineer, I guess. I don't know. That it took about 3 months to complete all these things. And as you can see, I used TypeScript, Python, JavaScript, Vue.js, a bit of Markdown, obviously, Makefile, my favorite thing in the world. And when you actually highlight what makes the customer experience, it's actually this. It's very little code compared to what you normally would expect. If you weren't using some of those serverless pieces, you probably would expect a couple 10,000 or more lines of this very, very easily. It's also fair to say that some of the airline industry does a lot more complex stuff as well. So it's not apples to apples. But at least it gives an idea that all of that create, update, read, delete, you can do all of this without any code whatsoever. So let me show you this, how that actually looks. Static is an interesting thing. All right. Can I? So this is how the front end looks like. I'm going to make a booking. Then I start showing the operations pieces, distributed tracing, how you can do some of those best practices yourself, and walk you through the code so you can have a look. So I've done a basic flight from London Gatwick to Madrid. It's a place I was looking at after Brexit, but Brexit didn't happen, so you know. So after I got these flights in here, you can see how the flight looks like. In fact, it's even actually responsive. See this? I know, it could be basic, but to me it was like, oh my God, I made it. And you should also be able to filter those flights for a particular price or time schedule. So let's select a flight that costs 1,000 euros. I'm not paying, so why not? So I go and start actually getting details like this. Let me just check one thing here. And I can use one of the Stripe fake cards. And once I do this, and I grid upgrading now, that's doing that pieces of talking to Stripe directly, making a pre-authorization. If the Wi-Fi is good to me and it works, I should be able to receive an email now. And I should also be able to see a booking, for instance. And then once I click on my booking, I should be able to see booking reference, where it goes. I could possibly cancel or check in. And because I made a booking, I should also be able to see those loyalty points be increased now. And you can see it was. Behind the scenes, I'm going to increase the screen, so don't worry if you can see it yet. Let's do this. Let's try to refresh this and see how. OK. Wi-Fi, I need you. All right, let's try again. Well, someone's playing with me now. So you can stop downloading the whole. You can stop Maven package if you. OK. That's OK. I will probably do it locally afterwards. So the whole point is actually this. Oh, actually, I had a filter. You were supposed to help me here. So here, of course, I will never see it. It's only showing HTML. So, you see that? OK, cool. So this is actually the GraphQL. Behind the scenes, GraphQL is pretty much a HTTP post. It's nothing really special. If you look inside, you will see that this, you'll be sending multiple headers. And once I look at the response, it's just JSON. But all of this integration, the contracts, the front end knows it up front. It doesn't need the back end anymore. In fact, serverless now, we spend more time in the front end than the back end now. How does that work behind the scenes? This is how the schema looks like now. I have a type flight. I have the model that I showed you. The optimization of that particular flight search, which I didn't add in the slides, but you can see it. All of the data fields. And this was one of my new favorites compared to REST. If you ever wanted to sunset a REST API, you had to do versioning, /v1, /v2, and things like this. Here, what you can say is that the only piece I'm trying to sunset is seat allocation fields shouldn't be used anymore. Or when people use it, they should have a clear message that, hey, by the way, use something else. And you just do this by saying @deprecated. And best of all, you get analytics on top of that and your logs as well. So you can quickly see who are the customers that are still trying to use that data field, for instance. If I go back to booking, it's slightly more complex from what you already remember. The @model, the @auth, @key, and things like this. And you see the connection and some of those pieces as well. So if I go now to the code itself, if I go to GitHub, this is actually the repo. where you can find more information, and some of the pull requests are already open. What I want you to pay attention here is everything inside Amplify is the one managed by Amplify CLI. Don't touch this folder, ever. Like, seriously, don't. I broke so many times that I don't want you to do it. And then inside source, you have the backend, end-to-end tests, front-end. End-to-end tests, we're using Cypress to actually basically search for a flight, book a flight, and things like this. The front-end, you know, Vue.js, obviously, perfect. And then that graph that I showed you, bookings, catalog, loyalty, that's exactly how it looks like, these components. Every action makes a call, API call, the GraphQL statements, mutations, all of this is being generated, by the way. And on the back end, if you're interested into the Lambda functions, API gateway, or serverless application model, SAM, it's all here. The booking has all those Lambda functions, make files, PyProjects, and a bunch of more advanced pieces. And every folder has its own Lambda function, its own event JSON for local testing, its dependencies. And I also have a log processing, all of the best practices that we normally would tell you in cloud.logs, it's all baked in that single file. So you can go and check yourself. If I were to look into one of those codes, for instance, to show you, this is all the code that I actually had to write in addition to this. All of that tracing that I was telling you to do is actually this. I open sourced that library for Python only to see how customers' reaction would be in the feedback. So if you do Python, I will show you the URL. So by doing these 2 lines, we are doing structure logging with logger setup and distributed tracing by doing this as well. And when I mentioned to you that tracing is good, but it's only good depending on how much context you have, if I look for annotation, see this, booking status. When my tracing gets sampled, not only I know which services you went through, but I also know that a booking status has been canceled, and I can start filtering all those traces and say, show me all the transactions that the booking has been canceled, and latency was higher than X, and the customer was X, and yada, 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 yada. So let's see that what we just did, how much we can see in distributed tracing, so you can see in reality. So that's how it looks like now of the booking process we just did. It's not the whole project yet, it's just a minor piece, but at least it goes to show you how those transactions go. Remember when we were trying to get the loyalty data? That's what it is. Let's say we want to get the payment piece. We went to collect payment, and that call another API. That went to Stripe. It went to get configuration details. If I were to click on this one, I click in View Traces. Because there was only one request, there's not going to be much in here. But what I can also see here, which is where the important piece is I can find out what was the booking. Was that a cold start? If it was a cold start, was a single function or across the board? And you can start finding payments, payment status, which step functions actually started all this as well. And you can go back and trace it. What's even better is this hidden feature in Xray. It's not hidden, it's just because we need to do a better job in there. Can you see this little button here? That's the best feature of Xray. By clicking here, I can do these annotations, using these annotations in a way that I can say, only show me all the requests that the latency was high enough. Or show me all the high downstream latency that things went horribly wrong. Or show me payments that failed. Basically what this happens is if I were to click in here, the way you do this is by saying, show me all the traces, all the nodes upstream, downstream, where the annotation payment status was equal to failed. And that also creates a CloudWatch metric, which you can alarm, and you can start doing composite alarms as well. Let's try to make that booking fail so you can see the opposite side as well. Remember what I mentioned I use step functions? That's how it is now, right now. So if I click in here, and I go to, I can do this, I'm sure I can. No. That's from the picture you saw it. Reserve the flight, everything else worked successfully, right? It's kind of an easy one. But actually make it fail. If we're trying to collect the same payment, that ideally should fail because you cannot collect the same payment twice. We do our dependency here. So let's try to do fail payment. And then we just change this thing so we get the right annotation. And hopefully, we should see a divergence in here, going from here. Yes. That time I was like, oh my, live demos is kind of tough sometimes. So you can see that it went back in here. What's good about this is different from AppSync pipeline resolvers, I can go back in time and see exactly what was the input, output, have better retry policies and things like this. I could have the input, what was the output, the exceptions, the logs, and everything else. If I go back to Xray now and show me the last 15 minutes, show me only payments that failed. You see these pins here? Ideally, if tracing has been already in place, now all that graph becomes more specific one for me. And I can create multiple views per customer, per view, and things like this. If I go now to collect payment and I try to see that trace, for instance, I will see that that specifically failed when I call my function inside my Lambda collect payment and hit the API. And it failed because I got a 500 from Stripe because payment has been already collected. And if I go back to the same trace and I start looking for payment status, you can see failed. And I can see exactly where it came from. Remember the name now? Failed payment. So you see how I can start correlating things? It's a much different approach of actually doing it. Whether using GraphQL, AppSync, all of those things still apply. If I were to go to logs as well, to kind of give you a glimpse, see how much of a difference it is by having a JSON. I can start using CloudWatch log insights to start querying that piece as well and create metrics for this. So much so that I even created this. In my dashboards, just by using logs and nothing else, I've got all this information now. Top 10 requests, all the pieces I showed you on the presentation, all of this come from logs. All the operational details I want to know and troubleshoot if I needed to. Field statistics, which customer, which operation, how many times it failed, how many times it retried. All of this you get by structured logging. All you need to do is JSON output, nothing else. And like I promised, if you are doing in Python, I would love your feedback. This is in beta right now. That's the tracing structure logging pieces. That's a library that I just open sourced last week. That I'll start with Python first, best language, but we will do Node.js and other pieces afterwards once we lock it down the APIs. If you install this library in Python, just by doing, there are 3 features that I will start for now. You can do the custom tracing, like I'm doing right now with you and showing you up, just by doing this, annotating your functions. That's why I saw the collect payment in the trace. And when you do structure logging, you set up the logger. And this, we already do the conventions. I think it's right. Collect functions, function version, function ARN, and things like this, and cold start. And this is the new one that I will change because of the new announcements we made last week as well. I didn't that graph that I showed you in the dashboard, I was showing successful payments, successful bookings. All you have to do is this. In your code, log metric, name of it, the unit, the value, the namespace, dimensions. And this will asynchronously call CloudWatch and simply create that metric for you and doesn't have any impact on the performance. That's a microsecond thing. That's simply a print outside. And I will change this to use the new CloudWatch metric format. So I'll stop here for now and then conclude this piece. The message I wanted to give you for all this is not only to show how I learned all these pieces and how hard it was to do CSS. That's not the point. The point is that if you look at the number of lines of everything we've done, including tracing, all of this, most of these pieces were code auto-generated. And all we actually did was actually start with a schema. Then from there, we created all the functions we needed. Prototyping has never been much easier than that. I mean, I've been doing this business for quite some time in cloud. I've been working for AWS for over 6 years. And I barely start writing any code. I just start with JSON now, do my schema, and I start from there. If my idea doesn't work, I spend nearly nothing. It's much easier to start. Any code that you write, if you're not doing tracing, if you're not doing structure logging, metrics, and all this, someone else is going to be responsible for your code afterwards. Code is liability. If your customer is having a bad performance, someone has to go and troubleshoot and improve your code. No code is better than ever. So that's why I'm actually looking into serverless and Amplify and all those pieces as well. If you are interested in something even deeper than that, these are some of the sessions that are related. I will give you my personal preference and my personal favorite, as every year I do. The last one, I couldn't spend too much time on authorization because it would be overlap. The last session, MOB308-R1, it's my favorite session if you are into authorization. That will show you all possibilities on how you can do with React or whatever framework you're using, into how you do a much more fine-grained detail authorization per field, per type, service-service communication, or even better, you can even use multiple authorization mechanisms within the same type. With that, if you want to continue that conversation, I'm very active on Twitter. Ping me anytime. My DMs are open. And I thank you so much for coming. Appreciate that.